All right, now that we have a basic idea of what polarization is, now we can really start to understand this method of charging, which is charging by induction. So in order to charge something by induction, you're going to start with a neutral object, as demonstrated here, and you're going to polarize that object. Now it needs to be a conductor, because to really get these electrons to move, you need to have a material that allows the free movement of electrons. You can cause polarization in an insulator, but not only to a small degree, not enough to actually charge the object, because the electrons can't physically move to the opposite side. So when we polarize this conductor, in this case by bringing a negatively charged rod, those electrons are going to move as far away as possible, which in this case is the left side of that object. The next thing you're going to have to do while it's in its polarized state, you need to what we call ground the conductor. Ground just means provide a conductive pathway, either to the object or from the object, depending which way electrons want to go. Your hand would work fine, a copper wire acts fine, anything that can conduct electricity. So you polarize this object. If you make contact, these electrons still would like to be as far away as possible from this negatively charged rod, whereas prior to touching the rod, that was the left side of the sphere. Well, now it's further away. You can get further away because you can get to the person's torso, their feet, their head. You can physically get further away from this negatively charged rod. So the electrons will actually jump, or maybe not jump, they'll pass from the sphere into your hand. You might get a small shock if enough electrons make that transfer. You then need to remove the ground. Okay, so while those electrons are being forced into your hand, you then take your hand away or you remove the ground. And at this point, granted, there would still be some electrons in here, but most of the electrons or some of the electrons have been forced out of this or polarized out of this into your hand. And we actually end up, therefore, with a positively charged object because we've basically scared or repelled electrons out of this object and into your hand. All right, the same exact thing can occur if we flip this around. So I'll just walk you through the same process with a slightly different result. If we take the neutral object, but we polarize it with a positively charged rod, well, now the electrons are going to be attracted. They're going to want to get as close as possible. So instead of fleeing to the left side, they're actually going to migrate to the right side to be as close as possible to this positively charged rod. You're going to ground the conductor, in this case with someone's hand. The difference, however, the electrons in the sphere don't want to leave the sphere. They would very much prefer to stay in the sphere because the sphere is right next to a positively charged object, which they love. So the electrons in the sphere aren't going to jump into your hand to get away. They're going to stay exactly where they are, which is right next to a positively charged sphere. Your hand is neutral. Those electrons are not going to choose a neutral object over a positively charged object, so they'll stay where they are. But the electrons in your hand have the same choice. Do they want to stay in the hand, which is neutral, or do they want to move towards a positively charged rod? In this case, they are actually going to leave your hand. You can almost think of it like they're getting sucked out of your hand to be near that positive rod. And then if you remove the ground, you'll wind up with an object that now has more electrons than it started with. Instead of repelling them out of the object, you kind of sucked extra electrons into the object by enticing them with this positively charged rod. So just to kind of wrap up the conditions for conduction, and then we'll look at a few examples. You're going to start with one charged object and one neutral conductor. So you need to have a positively or negatively charged object. In my examples, it was a rod. And you have to have a neutral conductor. It must be metal, some kind of material like that can conduct electricity. You're then going to polarize that neutral conductor. You're going to bring the charged object, whether it be positive or negative, close to, but not touching. If you allow them to touch, that's conduction. We want induction, so close to, but not touching. You're then going to ground that neutral polarized conductor. Those electrons are either going to move into the hand if it's a negative rod near the sphere, or they're going to go from the hand into the sphere if it's a positively charged object near the sphere. You're then going to remove the ground so that after those electrons have either left or entered the sphere, you're going to break that contact so that they can't reverse direction. And you will end with a conductor that has a charge opposite of what the initially charged object was. And what I mean by that, by initially charged object, I mean the original charged object that we started with. So I'm going to go back here quickly. I want to show you exactly what I mean. So in this case, you'll notice we started with a neutral conductor and we used a positively charged rod. Well, I used a positively charged rod, and if you jump down to the end, I wound up with a negatively charged object. So if you use a positive rod to charge something through induction, you get the opposite, a negatively charged object. Likewise, if you use a negatively charged rod, your end result is a positively charged object. If you use a negative rod, you're going to repel electrons out of the object, leaving it positive. If you use a positive rod, you're going to suck electrons into that object, making it negative. So just make sure that you understand the conditions required, because this one's a little bit more detailed, and understanding how polarization plays a role is going to help you understand this method at a much deeper level. In the following 2 videos, I'll give you 2 examples, and you'll have to use polarization and the concepts of induction to try and figure out whether or not the object has an ending charge of positive or negative based on what occurred in the example.